everybody. Hi, welcome to Momentum with Vedantu, guys. How are you? Shreepalaji is here, Surinder Singh is here, Entertainment 2015 is also here. Hi, everybody. Entertainment 2015 is basically V Krishna. I think that's V Krishna. Kaushik is here, and Abhyuday is here. Awesome, that's awesome. Everybody, hi, how Abhyuday, I'm good. Samnaran, hi. Samnaran, the poll results are in, and we have to shift the classes from 4 to 5, and we are working on that. Okay, we'll definitely shift the classes from 4 to 5. Definitely. Don't even worry. Okay, very soon. Okay. The poll results, guys, is basically there was a poll on the Telegram group regarding the timings. I think some of you want the timings from 4 to 5 as far as our session is considered. Correct? I think Sam Niran is definitely the one who wants the session from 4 to 5. Definitely. Yeah, definitely. Okay. Yeah, Kaushik, I will share the notes fastly. I will share the notes fastly. Don't even worry. Okay. I will do that as soon as I finish this class. Not finish this class, the next class. 4:45. By 4:45, the notes will be online. Okay. Don't even worry, guys. Yeah. All right, guys. All right. Shubhamangari, hi. Jishnu is here. Superb. Shravani Reddy is here. Shravani, I hope you found the notes. Okay. So if you found the notes, good. If you did not, I will upload it. Don't worry. Okay. All right. Mm-mm-mm. Just my favorite student. Just my favorite student. Kaushik, my tips for droppers is what are you preparing for, Kaushik? What are you preparing for? NEET or JEE? I hope I will share definitely Shravani. I hope I will share the notes. Okay, without fail. All right, the JEE Kaushik. The main tips is work more on your basics because in JEE the questions for JEE, do a lot of practice. Okay, do as much practice as you can. At least solve every day, at least solve 90 questions. Okay, you're at home, you have time, keep solving questions. Keep solving questions. Target 90 questions every day. You do that, you will have very good. Okay, so make some mocks for bit set. Okay, I will probably do that. Okay, all right, Shubhamangari, I will do a strategy video for 2021 as well. Definitely. Okay, chalo. Guys, so let's start today's lecture. If you're here for the first time, this is Aaditya Pandya. I'm the master teacher here at Vedantu, Momentum with Vedantu, and we are going to study Prism Part 2 today. That is the eighth lecture in the series of ray optics. If you haven't seen the previous ones, it's down there somewhere. Please find them and watch them. Okay, so today is Prism Part 2, guys. But before we get to that, let's talk about who gave the first correct answer, and that was Spaceman. Okay, that was Spaceman. Spaceman did give the correct answer. He didn't write the unit. Spaceman, you had to write the unit degrees. Okay, because otherwise I wouldn't know. Otherwise, I wouldn't know whether it's in radians or in degrees. Okay, so I will do that. You have to do that without fail. Okay. All right. Is Spaceman here or not here? Spaceman here or not here? I don't know if he's here. Okay. Yes, Jishnu, I will. Am I buffering, guys? Am I buffering? I think my internet is working very well here, but still, if I'm buffering, I will do something about it. Okay. Yes. Alright, so I will start the next chapter that I will start. We will have to talk to you guys only, and based on your opinions, we'll start the next chapter. Okay, but for now, let's do Prism Part 2. Okay, we will talk about the second chapter of Prisms. We'll talk about the second chapter of Prism, second lecture of Prisms, and today we'll talk about thin prisms. Okay, today we will talk about something called thin prisms. Now, guys, what exactly are thin prisms? What exactly are thin prisms? So prisms which are thin, as in their angle of prism is very small. Okay, where their angle of prism is very small. Such prisms are called thin prisms. Now, here, let's say I have a prism. Let's say I have a prism with angle of prism A. Now this can be considered a thin prism if A is smaller than or equal to 5 degrees. Okay, 5 degrees is an arbitrary number that we have taken, but in general, this is just to give you an idea. If this angle is small, then we call this a thin prism. Okay, where A is smaller than 5 degrees. Now, in such a case, guys, what happens is that if any light ray is incident on it, okay, and it gets deviated on from this prism, okay, it gets deviated from this prism. Let's draw this. Let's extend this. Oh my God. Huh. Let's say it gets deviated. Now, if I ask you what is the formula for delta minimum, guys, do you guys remember what is the formula for delta minimum? What is the formula for delta minimum? No. Do you know the formula for refractive index in terms of delta minimum? What is the formula for refractive index? The mu is equal to sine A plus delta minimum divided by 2 upon sine A by 2. Sine A plus delta minimum divided by 2 upon sine A by 2. Do you guys remember? Do you guys remember? This was the formula for minimum angle of deviation. This is the formula for minimum angle of deviation. Now, if you know small angles, then in this case, these are small, A is a small angle, then delta min will also be small because angle of prism is very small, delta min will also be small. Okay, and A is already small. Both these will be small angles. So I can say that for these two angles, sine sine A plus delta minimum divided by 2 will approximately just be equal to A plus delta minimum divided by 2. Similarly, sine A by 2 will just approximately be equal to A by 2. Okay, and if I substitute that, guys, if I substitute that in the actual equation, here sine will go away, here sine will go away, and this is what will remain. This is what will remain. Now, from whatever is remaining, if you cut out 2 and 2, okay, you get mu is equal to A plus delta minimum divided by A. You cross multiply, you get mu times A is equal to A plus delta minimum. And this gives you the final equation. This gives you the final equation once again. This gives you the final equation. What? That the delta minimum here is, guys. This is the final equation. Delta minimum is equal to what? Delta minimum is equal to mu minus 1 into A. Do you guys see that? Sir, can CBSE further reduce syllabus? Ajay Acharya, I hope not. I don't want them to because it's important that you study everything, even though it feels hard. I would rather have them extend the time rather than reducing the syllabus. But let's see. Okay, I would prefer them extending the time than reducing the syllabus. Okay, now this is the delta minimum, the minimum angle of deviation for a thin prism. Okay, now the thing is, guys, the thing is that as long as this angle, in case of thin prism, as long as this angle is small, as long as this angle is small, as long as I is small, okay, I is not mall, is small, okay, your delta will always be equal to, your delta will always be equal to mu minus 1 into A. Okay, as long as I is small, delta will always be equal to mu minus 1 into A. Now, I have given proof for the first statement. It looks very similar to the second statement. This, you just believe me without proof. Okay, this you just believe me without proof. The first one I have given you the proof for. Now, I hope everybody knows the difference between delta minimum and delta. You guys remember the graph? You remember the graph that we drew between delta and I? From that graph, you cannot see here, but for small prisms, the angle of deviation is more or less always equal to mu minus 1 into A, as long as the angle of incidence is small. Okay, as long as the angle of incidence is small. Now, let's talk about one more thing. Let's talk about the next thing. Next thing we've got to talk about, guys, is something called Cauchy formula. Okay, Cauchy formula. Okay, what exactly is Cauchy formula, guys? So when light enters from one medium to another medium, when light enters from one medium to another medium, okay, the speed of light changes, and the speed with which the light travels in the second medium depends on the refractive index n. Okay, here n is the refractive index. Now, what Cauchy found is that n depends on, what Cauchy found is that n depends on, first, the type of material medium. Okay, now that is very simple. Okay, basically, if you have glass, the value of n will be different. If you have water, the value of n will be different. And second thing, he found that n also depends on wavelength of light. N also depends on wavelength of light. Okay, so for example, violet light will have different wavelength, red light will have different wavelength, and all the colors in between will have different wavelength. Okay, and to actually give the value of refractive indexes for various different wavelengths, he gave a formula. Okay, to give the to calculate the refractive index of various different colors, he gave a formula. That formula is n is equal to a plus b by lambda square plus c by lambda raised to the power 4 plus dot dot dot. Okay, here A, B, C, and all are constants. Okay, this is called Cauchy formula. This is called Cauchy formula. Now, as far as you guys are concerned, you need to forget about all these extra terms. Okay, you need to forget about all these extra terms. They are not there for you. You just remember the formula n is equal to a plus b by lambda square. Now, if you see, guys, if you see, you have seven colors in a rainbow. Okay, you have violet, indigo, blue, green, yellow. O is what? O is what? O is R. O and R is red. Okay, O is. Oh my God, I don't know. I don't know. I don't know. Okay, now the Shravani Reddy is asking, sir, explain the terms in A, B, and C. These are constant that Cauchy gave. Okay, these are the constant that Cauchy gave. These are not important for us right now. Okay, don't worry about it. Okay, O is for orange, exactly. Now here, guys, here, Are Shubhamangari, I'm coming to it. I'm coming to it. Now, guys, you have to remember that as you move from violet to indigo, as you move from violet to red, not violet to indigo, as you move from here to here, what happens is that the wavelength of light increases. Wavelength of light increases. Can you see? Violet has the smallest wavelength and red has the highest wavelength. Now, according to Cauchy's formula, therefore, as you move from here to here, if wavelength is going to increase, then the refractive index is going to decrease. That means as you move from left to right, your refractive index decreases. Okay, basically what I'm saying here is that the refractive index of violet will be bigger than refractive index of indigo, which will be bigger than refractive index of blue, which will be different than refractive index of green, which will be different than bigger than refractive index of yellow, which will be bigger than refractive index of orange, which will be bigger than refractive index of red. All these different colors will have different refractive indexes. All these different colors will have different refractive indexes. I hope everybody understood. Yes, I hope everybody understood. Okay, now you just need to remember this from here, that the color which has the highest refractive index is violet, and the color which has the lowest refractive index is red. This part you guys will remember. This part you guys will remember. Everybody will remember. I hope you guys will remember. Okay, now N is C. Kaushik is asking, sir, but refractive index is for glass, not light. Yes, But understand, Kaushik, for refractive index of glass, it is different for different wavelengths. Okay, refractive index of glass for a particular wavelength might be 1.5, and for other different wavelengths it might be much higher than that. Okay. By the way, refractive index of glass for microwaves is almost around 10 to 15. Okay, that's much higher refractive index. If you change the wavelength, the refractive index changes. Refractive index depends not just on material medium. That's what I said here. Refractive index doesn't just dependent on is not just dependent on material medium. It's also dependent on wavelength of light. It's dependent on two different things. Okay, I hope everybody understood. Really hope everybody understood. Okay. Anyways, so after you find this, then you realize that in this case, what happens if I incident a white light, basically mixture of all different colors on a prism. Okay, and this, by the way, guys, is a thin prism. So let's say I incident white light on this prism. If I incident white light on this prism, like this, white light. Okay, white light, guys, is basically mixture of all different colors. Okay, so here all the different colors will have different deviations. So deviation of violet colors will be refractive index of violet color minus 1 into A. The deviation of red color will be refractive index of red color minus 1 into A. By the way, tell me which will be bigger? Which will be bigger? Deviation of violet will be bigger, or deviation of which of the following statement is true? Delta V is bigger than delta R, or delta V is less than delta R? Tell me which is true. A is true or B is true? You guys should know this. You guys should know this. A is true or B is true? A is true or B is true, guys? A is true or B is true? Everybody should know this. Everybody should know this. Kaushik is correct. Swa, you made a mistake. Shravani, you also made a mistake. Here, you have to remember, since violet color has higher refractive index than red color, therefore, violet color will have more deviation than red color. If you look at the formula, you will realize that. If you look at the formula, you will realize that. Okay, so now both these light will undergo refraction, undergo what? Deflection, but both of them will have different deflections. Okay, so if you follow red light, the red light will go something like this. Okay, and then something like this. And if you follow violet light, now I don't have a violet colored pen, but I do have a blue colored pen, so I'm just going like violet also here. If you follow violet light, the violet light will go from here and go from here. Okay, I hope everybody understood. Here, this violet light will undergo much more. Is this why I have chosen the correct color, right? This is the violet color. Okay, and the violet light will undergo much more deviation compared to red light. Compared to red light, it will undergo more deviation. Okay, and if you see all the other colors will be in between. All the other colors will be in between. Orange will be here, then yellow will be here, and then blue will be here. And I cannot make all the seven colors, guys. I cannot make all the seven colors. I will just make three, four. Okay, I will just make three, four. Okay, but all the other colors will be in between like this. I hope everybody understood. Okay, this phenomenon, guys, this phenomenon is called what? Can you tell me what is this called? What is this called? What is this called? This phenomenon is called dispersion. This is called dispersion. This is called dispersion. I hope everybody understood. Really hope everybody understood. Okay. This is called dispersion, where white light is splitting into all different colors of light, violet, red, and all of them. Okay, I hope everybody understood. I hope everybody understood. Okay, now, so you have to understand that whenever there is a refraction through a prism, always two different things happen. Okay, one is deviation because of the refractive index. Every light will deviate, but every color will deviate by different amounts. So because of that, the colors will split apart, and the splitting apart is called dispersion. Colors will split apart, and the splitting apart is called dispersion. I hope everybody understood. Really hope everybody understood. Really hope everybody understood. Okay. Now there are some terms here that everybody needs to know. There are some terms here that everybody needs to know. What are the terms here, guys? What are the terms here? Let me talk about it. Okay. T E R M S. Everybody should know these two terms. Okay. The first one is called average deviation. The first one is called average deviation. Okay, what is average deviation, guys? What is average deviation? If you see here, all the lights are getting deviated. Okay, but there is one light which will be somewhere in the middle. There will be one light which will be somewhere in the middle. Now, everybody might think that that light might be green. Okay, everybody might think that that light might be green, but actually it's not green. The light which will be somewhere in the middle is actually yellow. Light which is somewhere in the middle is actually yellow. Okay, so average deviation is the average of deviation. Average deviation is the average of deviation for all lights. This is the average of deviation for all lights, and that average deviation is generally for yellow light. Okay, the yellow light, the deviation of yellow light is called, yellow light is considered as the average of all of these lights because it undergoes the average deviation. So yellow light, the deviation of that is called the average deviation, and that is in general equal to how much? Mu v, not mu v, ny minus 1 into a. Now here, can anybody tell me what ny means? Ny means what? Can anybody tell me what ny means? Ny means what? It means refractive index of yellow light. Ny means refractive index of yellow light. Okay, I hope everybody understood. Guys, if you understood, please give me a thumbs up so far. If you understood, please give me a thumbs up so far. Okay, now if you understand that, then the next thing you have to understand, is something called, if you understand this much, the next thing you have to understand is something called, one second now. Let me remove this, let me remove this, let me remove this. Hmm. Next thing that you have to understand is something called angular dispersion. Okay, it's sometimes also called angle of dispersion as well, or it's called angular dispersion. This angular dispersion is called theta. Okay, what exactly is angular dispersion? So once again, let me make a small thin prism. Okay, on this thin prism, let's say I incident a white light. What happens to this white light? It splits apart into various different colors. Let's say the red color goes up and the violet color goes down. I don't want to make violet. I like blue color better, so I'm going to make blue color here. Okay, but imagine it's a violet color. So I have the violet color here and the red color here. Okay, I have violet color and the red color here. I hope everybody can see that. The angle made between these two, the angle made between the two extreme light rays is called angle of dispersion. The angle made between these two light rays is called angle of dispersion. Now guys, I have made a very simple diagram here rather than a complicated diagram. So angle between these two is called angle of dispersion. Now if you extend this incident ray, like this, okay, what you will find is that this angle is the deviation of red light. Okay, and what you will also find is that this angle is deviation of violet light. Okay, deviation of red light, deviation of violet light. I hope everybody can see that. Now, if I ask you what will be the value of theta, then from the diagram, what can you tell me? What will be the value of theta, guys? I think everybody should tell me what will be the value of theta. What will be the value of theta? I know you know, I know you know. From the diagram, guys, tell me. You know, you know, you know, you know. Hmm. Yes, it will be equal to delta V minus delta R. I hope everybody can see that. Kaushik is exactly correct. Okay, now what exactly will be delta V? If you guys remember, this is NV minus 1 into A. And what exactly is delta R? Deviation of red light, and R minus 1 into A. Okay, Shubhamangar is correct. Shri Balaji is correct. Very good, guys. Very good. I love when you guys respond so fast. Okay, so when I substitute both of these, you will get theta is equal to NV minus 1 into A minus NR minus 1 into A. Now, guys, if you see, a few things will get cancelled out here, and the final formula that will remain is this: theta is equal to NV minus NR into A. Do you see this? Theta is equal to what? Theta is just equal to NV minus NR into A. I hope everybody can see it. Can you see it, guys? Can you see it? Can you see it? Can you see it? I hope you can. Okay, this is the formula for angular dispersion. This is the formula for average deviation. Okay, average deviation and angular dispersion. I hope everybody understood. Now, if you know these two terms, guys, if you know these two terms, then there is a third term that you need to know. There is a third term that you need to know, which is called a third term that you need to know. One second, one second, one second, one second, one second, one second. There's a third term that you need to know, and that term is called dispersive power. That term is called dispersive power. Okay, this dispersive power is represented by the letter omega. Okay, and what exactly is dispersive power? What exactly is dispersive power? Dispersive power, you have to remember, is defined as the angle of dispersion, the angle of dispersion divided by average deviation. Angle of dispersion divided by the average deviation. By the way, average deviation किसका होता है? Which light undergoes average deviation? Oh God. Which light undergoes average deviation? The yellow light undergoes average deviation. Okay, so if I ask you what exactly is going to be the value of omega, so first of all, you have to remember theta is NV minus NR into A, and delta average is equal to ny minus 1 into a. If you substitute both of them here, you will get you will get the formula as nv minus nr upon ny minus 1. Do you guys see that? Do you guys see that? Do you guys see that? I hope everybody can see that. Now here, guys, if you look at this diagram, okay, if you look at this diagram, you have to see one critical thing. Okay, you have to see one important feature of this formula. If you see, theta value depends on A. Theta value depends on A. The value of delta average also depends on A. Okay, but the value of omega only depend. This is independent of A. This is first of all independent of A. Okay, and this is only dependent on the value of refractive indexes. This is only dependent on value of refractive indexes. Okay, so this basically can be called a material property. Therefore, it is a material property. Now, do you guys know what material property are? What do I mean by material properties? Okay, material properties is basically those properties which get fixed as soon as you choose the material. So if I choose a prism of made up of glass, then its dispersive power is already fixed. Its delta average might be different and its theta might be different because those two values depend on A. But if I know that it is made up of glass, then its omega dispersive power is already fixed. Okay, so it is a material property. It only depends on what material the prism is made up of. If you make it of glass, it will have a different value. If you make it of something else, it will have a different value. Okay, so it's a material property. It's a material property. I hope everybody understood, man. I hope everybody understood. Okay, now at this point of time, I need you guys to know one thing. Okay, and this is important. Remember, okay, what you have to remember that sometimes in exam value of ny will not be given. Okay, sometimes in exam the value of ny will not be given. You have to remember sometimes in the exam only they will only give you the value of nv and nr will be given. Okay, then what do you need to do in this case, guys? What you need to do then calculate, then take ny as average of nv and nr. Okay, or basically just do this. Ny is equal to nv plus nr divided by 2. Okay, just do this if the value is not given in the question. If the value is not given in the question, do this. Guys, did you understand? Guys, did you understand? If you did, give me a thumbs up. Give me a thumbs up if you understood. Give me a thumbs up if you understood. I hope everybody understood. Now, if you understood, I think then you are ready to do one question. If you understood, then you are ready to do one question. Okay, let me give you one question. So this is a question. The refractive indexes of a flint glass for red and violet are this and this. Find the dispersion produced by thin prism having a refracting angle 5 degrees. Okay, calculate this, guys. Calculate this. I know everybody can calculate this. Okay, Aluka Chalu champions. Oh my God, he also understood. Alright, guys. This is a simple question. I think you can solve this. Try to solve this and tell me the answer. I think everybody can solve this question. I think everybody can solve this question. Give me the answer in chat, chat, chat. Give me the answer in chat, chat, chat. I think everybody can solve this question. Give me the answer. Aluka Chalu champions. Yeah, I understand what you're saying, my friend. I definitely understand what you're saying. Definitely understands what you're saying. Thank you, Shrav. Thank you. Tell me, guys, tell me what will be the answer here? What will be the answer here? I know everybody knows how to solve this. You know. Tell me the correct answer, guys. Tell me the correct answer. So, guys, what you have to do is you just have to use the formula. Which formula do you have to use? You have to use the formula theta is equal to nv minus nr into a. Okay, which gives me the value 1.632 minus 1.613 into 5 degrees. Okay, which is 0.019 into 5 degrees, that is 0.095 degrees. This will be the value of theta. This will be the value of theta. I hope everybody understood. Really hope everybody understood. Okay, now guys, here in this question only, so the correct answer will be option D only. In this question only, I will ask you one more question. Okay, I will ask you one more question. Instead of telling me the value of theta, instead of telling me the value of theta, now I want you guys to calculate. Now I want you guys to calculate another value. Find average deviation. Find average deviation. Okay, now you don't have, obviously you don't have any options for this because there are no options here. So find average deviation produced by this. I know you can do it. I know you can do it. Please do it quickly. Tell me the correct answers. Shubhamangori, the value that you have given me is actually the value of mu average. Okay, that's an n average. Sorry, average refractive index. Okay, I want you to tell me the average deviation. How to do this, guys? How to do this? How to do this? So here, first of all, I will calculate the refractive index of yellow light. That will be 1.613 plus 1.632 divided by 2. Okay, that if you calculate will come out as 1.6225. 1.6225. I hope everybody can see this. I hope everybody can see this. Okay, now I have to calculate delta average or average deviation. It will be ny minus 1 into a. That will be 1.6225 minus 1 into 5 degrees. Okay, that will be 0.6225 into 5 if you do. That will be approximately equals to 3.1125 degrees. That will be approximately 3.1125 degrees. Okay, or you can just approximate it as 3.1 degrees. Okay, but whatever you want to approximate it as, it's okay. It's okay. It's okay. Right. I hope everybody I hope everybody understood. Really hope everybody understood. Now, guys, one more question for you, and this is this. I have You have to calculate the dispersive power of this medium. You have to calculate the dispersive power of this medium. Once again, a very simple, nice and forward formula based question. If you know the formulas, you can calculate the correct answer. You know the formulas, you know the correct answer. La 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 la. Huh. Everybody tell me the correct answers. Am I sitting? La 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 la, where is my chat? Why is it not? Yeah, there it is. There it is. Okay, everybody. Can you tell me if it's very, very low? Here, once again, NV is given as 1.60 and R is given as 1.50. So, NY will be equal to NV plus NR divided by 2. That will be 1.55. That will be 1.55. Very good. Very good. Very good. Okay, now I have to calculate also the dispersive power of this medium. Okay, so omega is basically NV minus NR upon NY minus 1. Okay, that will just be equal to 1.60 minus 1.50 upon 1.55 minus 1. That will be equal to 0.10 divided by 0.55. Okay, now what will that be? What will that be? 0.10 divided by 0.55. If you do, that is 0.181818181818181818. 0.181818181818, and you know where it is going. Okay, so the correct answer, guys, will be option A. I hope everybody understood. I hope everybody understood. Okay. Now let's talk about the final two things of this part. Okay, this is dispersion without deviation and deviation without dispersion. Now, these are very important topics. Okay, so basically, guys, what you can do is you can basically don't look at whatever is written here. Okay, just look at this diagram. Basically, what you can do is that in life you can have such a thing. In life you can have such a thing where you are basically combining more than one prisms. In life you can have such a thing where you are combining more than one prisms. Okay, now let's say I am combining two prisms in the following way. Okay, let me make this diagram, you will understand. How am I combining the two prisms? One second, huh? Stop suggesting design ideas here. Okay, so the first prism I will put like this. Okay, I will this and this. Okay, and the second prism, guys, the second prism I will just copy paste this. Control C, Control V. Okay, and just rotate this and put it like this. Right. Okay, so I have basically put two different prism here, guys, two different prisms of two different materials. Okay, let's say this is the first prism. Let's say this is the first prism. Okay, I will name this as the first prism. Okay, for this prism, the value of a refractive index, the value for refractive index for the violet light is NV1. The value of a refractive index for the red light is NR1, and the value of refractive index for the yellow light is NY1. Okay, all these three values will be different from each other. And also let's say its angle is equal to A1. Its angle is equal to A1. I hope everybody can see the diagram. I hope everybody can see the diagram. Next, let's talk about the second prism. Let's say this is the second prism, and for this prism, let's say the value of refractive index for violet light is NV2. The value of refractive index for the red light is NR2, and the value of refractive index for the yellow light is NY2. And the angle of this prism, let's say, is equal to A2. The angle of prism for this is equal to 8. Okay. Now, if you see, God, there are so many different numbers here. If you see, all these three numbers are going to be different from all these three numbers. Why are they going to be different from all these three numbers? Because both the prisms are made up of different materials. Both the prisms are made up of different materials. Okay, and A1 and A2 are also different from each other. Now, what will happen, guys? What will happen if I incident a white light on it? Okay, what will happen if I incident a white light? Okay, now first thing everybody has to understand. Okay, look at me here. First thing everybody has to understand is that if the white light is incident like this, one prism will bend it like this, and the second prism will bend it backwards. One prism will bend it like this. If the white light is incident like this, one prism will bend it like this. Okay, and the second prism will again bend it like this. Okay, both prisms will bend them in opposite directions. Okay, why will the prisms bend them in opposite directions? Because they are kept in opposite direction. Okay, I hope you guys understood here. Okay, so one prism will bend it like this and the other prism will bend it back like this. Okay, I hope everybody understood. I hope everybody understood. Now, if I draw all the diagrams, guys, it becomes very, very complicated. So I'm just going to make one line of a final deviation. Okay, in between whatever happened, I don't care. Whatever happened, I'm not going to draw perfect diagram for that. Okay, anyways, this will undergo some net deviation. This will undergo some net deviation. Okay, let's call this delta net. Okay, now guys, what will be delta net? So I can say that the net deviation which this light went through, net deviation which this light went through is going to be equal to deviation caused by the first one minus deviation caused by the second one. Why am I writing a minus sign here, guys? Why am I writing a minus sign here? Can you tell me why am I writing a minus sign? Why am I writing a minus sign? I am writing a minus sign. I am writing a minus sign because the first prism bends it in clockwise. Sorry, the first prism bends it in clockwise direction. The second one bends it in anti-clockwise direction. Okay, so overall will be the difference of both of them. I hope everybody, yeah, correct. Shubhamangori is correct. Okay, and by the way, here when I'm writing this, I'm talking about the average deviation. Okay, I'm talking about the average deviation. Also, this prism will also is also going to separate the blue light and the red light. Okay, not the blue light and the red light, the violet light and the red light. Okay, so let me just make the violet light and the red light as well. Violet light and the red light as well. Okay, and let's say the angle of prism, the angle of dispersion between both of them is called theta net. The angle of dispersion between both of them is called theta net. Now, here, once again, guys, if I ask you what will be theta net, then can you tell me what will be theta net? Theta net will once again be equal to theta 1 minus theta 2. Okay, why am I writing it as theta 1 minus theta 2? Because once again, one of them will try to put the violet ray down, the other one will try to get the violet ray up. Okay, similarly, one of them will try to keep the red ray up, the second one will try to get the red ray down. Okay, so overall, just in the case, just like how it happened with delta net, the net deviation, the same thing will happen. The same thing will happen with the net dispersion. Same thing will happen with the net dispersion. I hope everybody is following so far. I hope everybody is following so far. Okay, yeah. ओके आई होप ओ माय गॉड यहाँ पे चैट में तो कुछ तो हो रहा है ना चैट में कुछ तो हो रहा है आकाश देव आर यू फाइटिंग विद एनीबॉडी आकाश देव ओ हो is anybody fighting with anybody? Oh, if you're fighting, tell me. Okay, I will get popcorn. I want to see fights. I want to see fights. Okay, all right, guys. Shantanu Prabhudesha is asking a very good question. Shantanu is asking, sir, why don't the two prisms mix back to the white light? Shantanu, I will get to your question. Okay, there is a perfect condition when things are balanced when that happens. Okay, so I will get to that. I'll get to that. Don't worry, don't worry. Okay, so if you have this, guys, if you have this, then you can have two different special cases here. Okay, you can have, if you arrange two prisms like this, you can have two special cases. Okay, what are the two special cases? What are the two special cases? The first special case, guys, is called, the first special case is called deviation without dispersion. Deviation without dispersion. Okay, now this is a special case, guys. What happens here is basically, you know what, let me draw this diagram once again. Let's say I have this triangle and also this triangle, control C and control V. Okay, so what happens here is, guys, let's say I have white light incident here. Okay, let's say I have white light incident here. What happens is that white light splits into red and the blue color. Okay, so red and the violet color. Let's say this went into red and violet, two separate directions. Okay, it split all the colors apart into 7 different colors. Okay, but what happened here? What happened here? Now these two rays again got bent and got mixed together. these two rays again got bent and got mixed together and came out as a single ray once again. Came out as a single ray once again. Do you guys understand deviation without dispersion? Shantanu Prabhudeshai, do you understand? This, guys, is supposed to be a special case. Why am I calling this a special case? Because here, if I extend these two, there is some deviation. There is some deviation. Okay, there is some deviation. Okay, but there is no dispersion. There is no dispersion. Do you guys understand? Do you guys understand? Okay, yeah, the single ray is supposed to be white. Yeah. This is supposed to be white light. Okay, this is supposed to be white light which gets dispersed. I cannot make a white ray, right? Because I have a whiteboard here. So, yeah. So here, in this case, guys, in this case, what is the condition for it? What is the condition for it? That's pretty simple. Theta 1 minus theta 2 should be equal to 0. Okay, theta 1 minus theta 2 should be. Am I stuck? Am I stuck? Am I stuck? Yeah, I think I was stuck for a minute here. I think I was stuck for a minute here. Yeah. Okay, so theta 1 minus theta 2 should be equal to 0. I hope you guys can see that. Okay, which means theta 1 should be equal to theta 2. Theta 1 should be equal to theta 2. Okay, now guys, what exactly is going to be theta 1 and theta 2? So let me first go back to this as well. Okay, one second now. Control C and Control V, and let make you come down. Thoda sa, come down. Yeah, like this. Okay, now in this case, guys, what exactly needs to be the condition? One second. What exactly needs to be the condition? What exactly needs to be the condition? If you have theta 1 and theta 1 is equal to theta 2, basically what should be the case? What should be the case? If theta 1 is equal to theta 2, first of all, I will find theta 1 and I will find theta 2. What was theta 1? What was theta 1? Do you guys remember the formula for theta? What is the formula for theta? What is the formula for theta? Theta is equal to NV minus NR into A. Do you guys remember that? But since we are talking about the first prism, I will write down here NV1 minus NR1 into A1. NV1 minus NR1 into A1. Similarly, if I ask you what is theta 2, if I ask you what is theta 2, no, Shubmangari. A1 is equal to A2 is not necessary. Okay, A1 is equal to A2 is not necessary. If I ask you theta 2, once again, the formula for theta is NV minus NR into A. Okay, NV minus NR into A. But since we are talking about the second prism here, I will write it as NV2 minus NR2 into A2. NV2 minus NR2 into A2. So what is the condition that we have here, guys? What is the condition that we have here? The condition that we have here is very simple. It's basically NV1 minus NR1 into A1 should be equal to NV2 minus NR2 into A2. Okay, this is the condition for us to have a deviation but no dispersion. This is the condition for us to have a deviation but no dispersion. Okay, I hope everybody understood. I hope everybody understood so far. This is the condition for us to have a deviation but no dispersion. The white light goes in, white light comes out. There is no splitting of colors. There is no splitting of colors. Okay. Similarly, if I talk about the second special case, guys, if I talk about the second special case, let me remove all of this. Okay. The second special case is called, the second special case here is called, one second, blah 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 blah. The second special case is called dispersion without deviation. Dispersion without deviation. What exactly do I mean by dispersion without deviation, guys? What exactly do I mean by that? Let's say I have white light incident. Okay, now I'm not going to make what exactly happened in between, but let's say I have white light incident here like this. Okay, then what happens is that yellow light comes out like this. Okay, and and the red and the blue light comes out like this. Okay, now here if you see guys what has happened, here if you see what has happened, here I do have a day dispersion, I do have dispersion, but my light ray did not get bent. Here I do have dispersion, but my light ray did not get bent. Okay, so here what I will write is that delta net is equal to 0, but theta net is not 0. Okay, this is the second special case. Now here if I have to calculate the condition, what is the condition for this to happen? What is the condition for this to happen? Delta 1 minus delta 2 should be equal to 0. For this to happen, delta 1 minus delta 2 should be equal to 0. Now if I remove all of this, let me just remove this. Okay, so if I remove all of this, what will be delta 1 and delta 2 individually? Delta 1 will be equal to ny minus 1 into a1. Okay, ny1 minus 1 into a1, and delta 2, the average dispersion is once again ny minus 1 into a, but since we are talking about the second prism, I will write ny2 minus 1 into a. Okay, so I will just write down the condition here. The final condition that I will get is ny1, sorry, ny1 minus 1 into a1 should be equal to ny2 minus a2, ny2 minus 1 into a2. Okay, this is the condition for dispersion without deviation. This is the condition for dispersion without deviation. Now you have to see, remembering the formulas is not important here. You have to remember what it exactly means. Okay, you have to know that this is called dispersion without deviation and this is called deviation without dispersion. Dispersion without deviation, deviation without dispersion. Deviation without dispersion, dispersion without deviation. Okay, you have to know what each of them means. You have to know what each of them means. If you know that, you will be able to solve the questions effectively. Now, guys, based on this, I'll give you a question, but before that, let's talk about Vedantu. Okay, if you were thinking about getting a pro subscription, guys, then great news for you, great news for you. Now with my coupon code AAPPRO, guys, what you get is you get 30% discount. Okay, you get 30% discount, by the way, up to only 7,000 rupees, but you get 30% discount. Okay, which means that if you were going to buy a course, a 12-month subscription which was costing 31,799, it will now only cost 24,799 because of the coupon code. Okay, this is a lightning discount, guys. This will not stay for long. It's only a limited period offer. Okay, I don't know when they will take it back again, but if you want to get the pro subscription, you can do it. Okay, what do you get? By the way, many people might be confused, sir. What do we get? What do we get? If you get the pro subscription, basically you get full access to all the live courses where all the subjects are covered in great detail. They are taught in both the languages, English and Hindi. Okay, we have instant in-class doubt solving where you can ask unlimited doubts, guys, unlimited doubts. Okay, however many you want to ask, and you get to learn from India's best teachers, all of them having more than 5 years of experience from your home on any device you want. Okay. Anyways, if you want to get the pro subscription, guys, go to vdnt.in/ytpro and use my coupon code AAPPRO because for the limited period you will get 30% discount. Okay. Now Also, at the same time, if you haven't joined our Telegram group, please join our Telegram group. I'm going to share the notes and assignments and everything there. Okay, an assignment on ray optics is on the way. I will share it very very soon. Also, at the same time, guys, if you are still here with me, if you're still here with me, we have this question. Okay, now remember here, both the prisms are kept in the same orientation. Both the prisms are kept in the same orientation. What you have to calculate is you have to calculate delta net, sorry, you have to calculate theta net and delta net. What do you have to calculate? Find the total. They have only given one of these two options. Okay, they have not given the second one. So let's just assume that you just have to calculate angle of dispersion. Okay, find angle theta net, guys. Now remember, because these two are kept in the same orientation, theta net here, which one it will be? First of all, tell me the answer to my question. Okay, what will theta net be? I will give you two options. Theta net will be theta 1 minus theta 2 or theta 1 plus theta 2. Can you tell me which will be the options? Which will be the option if I have to calculate the net? If you have to calculate the net theta, what will that be? Shravani, if you want 100% discount, then stay on this YouTube channel. I'm going to upload all the videos for all the topics. Okay, don't worry. All right. Now tell me, guys. Tell me. Theta net will be what? Theta 1 plus theta 2, theta 1 minus theta. Ah, correct. Because they are in the same direction here. This will be the answer, and this is the formula that you will have to use. Okay. Using that, guys, calculate the answer and comment the answers in the comment section below. Okay, so that I know who did it correctly the first time. Okay, awesome. Also, at the same time, if you have any doubts, then you can send me your doubts on Telegram at AADITYAP832. Okay, this is on Telegram. You can send me your doubts. Okay, anyways, guys, that's it for today's session. I will see you again tomorrow. I had a lot of fun teaching you. This topic is my favorite because it's so simple and yet you can visualize it in a very good way. Okay. Anyways, guys, so I will stop here and we'll see you. What is today? Friday, right? I will see you on Monday. We'll see you on Monday. Yeah, I'll see you on Monday. Okay. And also, we'll have a special episode on Sunday, so we'll do that. Okay. So, have a nice day, guys, and see you again.